Hey, what's up everyone? Welcome to IggyCloud, my little corner of the internet where we explore cloud stuff, one byte at a time. I'm Sebastian, a .NET developer with several years of experience, mostly working as a consultant or a contractor for some pretty big companies. And I've actually been super hyped about distributed systems for a while now. I even wrote my engineering thesis on this topic. I built a full-on distributed systems from scratch, just me and a lot of coffee. And it was like a couple of years ago already. The repo is still out there if you are curious. I'll drop the link in the description. So yeah, I've loved this topic for a long time, but honestly, even though I started early, it took me a while to really understand how it works, what doesn't, and where all the complexity leads in real life projects. That's what IggyCloud is about, not pretending to be a guru, because quite frankly, I do not know a lot of things, but I'm trying to learn. And today, we are starting from the very beginning. What even is a distributed system? Don't worry, it's not a scary word. I'll keep it simple, real, and kind of fun. Let's go. So what we will cover today. What even is a distributed system? So we'll be speaking about the characteristic, how this system looks like, and do we even need that? Maybe we don't need it at all, and we just need a single powerful computer that will run everything, in the entire system in one machine. Few real world examples. So applications like Facebook, YouTube, or Uber. When do we use them? How they work, and what's coming next on the channel. So let's go. What is a distributed system? A distributed system is a group of computers, usually called nodes, that work together to act like a one big system. From the user's perspective, it just works. They shouldn't care, and really they shouldn't even know whether it's running on one server or 1,000. Technically, those servers communicate over protocols like HTTP, gRPC, or message buses. They send data between each other, coordinate tasks, and return the final result to the user. That's a distributed system in action. Let's take a look at how distributed systems power the platforms you probably use every day. YouTube. When you hit play, one service handles video streaming, another suggests what to watch next, and other take care of comments and tracking. It feels instant, but it's all handled by different systems working together. Uber. Booking a ride involves multiple services behind the scenes. Your location, driver matching, pricing, and the trip updates are all managed separately. Spotify. Playing music seems simple, but your stream, playlists, and recommendations are all coming from different parts of the system. Facebook. Scrolling, messaging, posting, each of these features run on its own service. If one has issues, like Messenger, the rest of the application still works just fine. So why don't we run everything on one server? Well, it starts that way. Most systems do. Early on, your whole application might run on one machine, one codebase, and one database, and that's totally fine. But as traffic grows, you need to scale. So maybe you add more CPU, more RAM, more disk space, and it works for a while. But eventually, like trying to widen a highway forever, it just doesn't scale anymore. Think of your app like a highway. At first, a 2-lane road is enough. But then, traffic grows, so you widen it. 4 lanes, 6 lanes, 8 lanes, but eventually, you hit a wall. Here's why. You run out of physical space to keep adding lanes. Managing that much traffic in one place becomes complicated and risky. And worst of all, if there is a single accident, it blocks the entire highway. That's what's happened with a single powerful server. Eventually, it becomes too expensive, too fragile, and too centralized. At some point, the smart move is to split traffic across multiple roads. or in our case, multiple services. That's why we moved to distributed systems. Let's talk about what actually holds a single server back. Every machine has 4 core resources: CPU, how much computation it can do; RAM, how much it can keep in memory at once; disk, how much it can store and fast it can read and write; network, how fast it can send and receive data. As your app grows, more users, more requests, and more data, these start to get maxed out. You'll notice things like the server slows down, request starts timing out, or services crashes randomly. So how do we respond to those limits? At first, you can go with vertical scaling. You upgrade the server. More CPU, more RAM, faster SSDs. It helps, but only for a while. Every machine has a ceiling. Eventually, you can't go any bigger, or it becomes too expensive or too risky. That's when you switch to horizontal scaling. Instead of making one server stronger, you add more servers and share the work. It's like hiring more chefs in more kitchens instead of giving one chef 10 arms. So, what do we gain? Scalability. Imagine thousands of users logging in at the same time, like on Black Friday. One server might crash, but multiple nodes, you can spread the load and stay online. Fault tolerance. If one machine fails and it's the only one, you're offline. Distributed systems allow others to take over instantly, so user might not even notice the problem. Flexibility. You can update or restart one part of the system, like payments or search, without shutting everything down. You can even use different languages, frameworks, or databases for different parts. Performance. You can place services closer to where your users are, like Europe, the US, or Asia, so things load faster and feel more responsive. But distributed systems solve many problems, but they create new ones too. More moving parts, more things can go wrong. Debugging across services is harder than in a monolith. More code is more tests, more deployments, more configuration. You need to things like logging, tracing, retry logic, failover, and monitoring built in. More powerful, but also more dangerous if you don't know what you're doing. Next up, we are jumping straight into the code. We'll start a real project based on .NET Aspire, Microsoft's new stack for building distributed apps in .NET. This won't be just a toy demo, it's something we'll build on over time, adding new features, refactoring, and introducing more advanced ideas like observability, message brokers, retry, scaling, strategies, and more. The pace? I want to get to the fun parts quick and explain the why as we go. So if you want to learn distributed systems by actually building one, you are in the right place. That's it for today's intro. Thanks for being here. If you are interested in cloud-native .NET development, distributed architecture, and real-world examples, hit subscribe and come along for the ride. We are just getting started, and I think it will be fun, hands-on journey. Catch you in the next one.